Okay, this is the second video in the Hewlett Packard 97S calculator series that I'm doing. I'm going to go through more of the manual here and show you some more. So we're going to start off with display and printer control. So I did go over a little bit of printer control in the last video, but this is just a little bit more information here. So yep, let's go. So the default status when you turn this on, this is a 2 decimal place display there at the moment. So 2 enter 3 multiply gives you 6.00. However, inside the calculator it's actually displaying the full notation. So when I type 2 in here for the 2 times 3 calculation, internally the calculator is actually seeing the number 2 as 2.0000 times 10 to the power of 00, and also the 3 that I typed in here as well to get multiplied by 2 to get 6, so it's seeing 3 as the same, times 10 to the power of 0, and 6 here is also being displayed the same, so all these zeros again, times 10 to the power of 00. But what it's displaying is actually only this section here, okay, because we're set to display of 2. So we can change the way it's displayed by the display key. So if I want to display to 4 decimal places, I can hit display 4. And there you can see the result. Display 9 will give us the full range, and back to display 2. You've also got scientific notation, engineering notation as well. I won't go too much into the different notations, but we can also do things like setting the fix. So if we have a number, say 123.4567, and we fixed that, it's fixing that to my 2 decimal places that I had the display set to. So you'll see 123.4, and then the 5 is rounded up based on the number that was coming after it, which was 6, of course. So if I change the display to 0, it drops the decimal point, everything after the decimal point completely. If I display out to 7, you'll see that we're displaying 7 decimal places here, and so you'll see the full number that was typed in. There's no rounding. But if I go back to display 1, again the 4 is rounded up to 5 because the number here was 5, so a 4 gets rounded up. Yep. And display 2, that's back to 2 decimal places. So yeah, that's just a quick note on fix. Okay, exponents are dealt with like such. So if we wanted to do 15.6 times 10 to the power of 12, you would type 15.6 exponent 12, which is 15.6 times 10 to the power of 12. If we enter that, we get 1.56 times 10 to the power of 13. Alright, so if we multiply that by 25, and now we see 3.9 times 10 to the power of 14. and on the printer it looks like that. Okay, and you can save time when keying in exact powers of 10 by merely pressing EEX and pressing the desired power of 10. So if you wanted to key in 1,000,000, which is 10 to the power of 6, and divide it by 52, you would key in EEX like so, and then you take the power you want, 6 enter, gives you 1,000,000, and then 52 divide, print. Quick note on overflow with the calculator. If you went power of 49 into that, so and then multiplied by that 50 to the power, you get this result here. Right, so we're right at the limit of the display of the power there. If we times that by 100 again, 100 times, the 9s indicate that there's an overflow. In the first video I went through some of the stack functions, and now I'll just go through some more advanced stack functions just to make the stack a little bit clearer. So if I'll just write this out here. So your stack consists of these 4 registers. X is displayed, that's what you're seeing on the screen. Okay, and then so if I hit 4, that's 4 in the X register, and enter that, 4 pops up to the Y register, and is also duplicated down here. I won't show that though because I'm going to type 3 in here, so that's how the stack looks now. And if I enter that, 4 pops up to Z, and 3 pops up to Y, and then 2 comes in here, enter that, so chain reaction, 4, 3, 2, and I'll type 1. So that's the contents of the stack there now, and we can look at that by shift print stack. Okay, so that's the contents of the stack as we see it written there as well. Now if I hit the roll down key, this is going to roll the stack down. So effectively what it does, if I do R down, roll the stack down, it effectively rolls the stack through. So 4 comes down, 3, 2, so 4's down here now, 3 and 2, and 1 basically comes into the top. So yeah, if I go ahead and hit roll down, we now have 2 in the X register, which is matches here, and then we can print the stack and roll down again, and now 3 is down here, 2 is popped in, it's come out of here and up into the top, and 1, and this is 4 in the Y register, and we can print that. Like so, and roll down again. We've got 4 in the lowest register and the X register here. So now 4 is here, 1, 2 and 3. Like so, and then if we roll once more, we've cycled right through, so ones come down. 1, 2, 3 and 4s come in to the top. Like so. So you can manipulate the stack, and I've also discussed in the other video about exchanging X and Y. If you wanted to clear the stack, you could just hit 0, enter, 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 so that just fills the stack with zeros. In addition to the 4 stack registers, there is another register called last X. This register preserves the value that was last displayed in the X register before the performance of a function. Quite handy for recovering from mistakes. The example here is that we want to divide 12 by 2.157, but after making an input mistake. Okay, so this is what we actually want to calculate, but we're going to just mistakenly input 3.157 instead. So okay, let's go through this. So 12, enter, and then I'm going to mistakenly put in 3.157, divide, and okay, so we realize we've made a mistake here. We can recall the last X. Okay, so I can bring back 3.157 here by recalling last X, so shift last X. Now it's displayed as 3.16 because it's being rounded up to 2 decimal places. If I display 4, we see that we get the full number there now. And we want to reverse the function, the divide function, to get us back to where we were. So reverse of divide, or the opposite of divide is times. So times that, you get back to 12. Right, and then you can now input the correct number, 2.157 divide, and we get our result. So that's quite a handy use of the last X. You can use it also to recover a number in a equation. So let's say you want to calculate 7.32 plus 3.6501123331 and divide that by 3.6501123331. So you can see these two numbers here are duplicates. You can do that easily by inputting your 7.32, enter, and whack in your number, and then you want to add the two together, and then you want to bring up your last X, which was what was last in the X register when before you added the two. So bring up last X. It's rounded up, as you can see, fixed to 4 decimal places here, and then just carry out the divide function, and there you have it. So just set the fix to 2 there, the display, and then you can print that result. So yeah, you can use that in programming as well. Any of these functions that I'm showing here can be used in programming. In addition to the stack and the last X, there are also registers, which are basically memory locations, and there's a set of primary registers and a set of secondary registers, and they range 0 through 9 and A through E. So there's also a special register I, which I'll go into in a later video. So you've got register E down through, so E, D, C, B and A. Register A is down there, register B, register C and register D. Okay, and then also you've got registers 9, 8, 7, 6, 5, 4, 3, 2, 1 and 0. Primary registers, and you've also got secondary registers 9 through register secondary 0. So yeah, it's got a bit of memory. To store a number, you might calculate 6.02 exponent 23 and store that in 2. I've switched over to normal, so we're going to get this printed out as a record. So store in 2. So we can see there the number that was input has been stored in register 2. Okay, so if we wanted to store the square of that number, we could just immediately square it right here, and then go store and choose one of the numeric, alphabetical registers, say B, store B. So now we've stored that number, stored this number in B register, and we can recall the numbers easily. So if we wanted to recall this number here from store 2, we just the recall 2, and there we have the number there. It's just printing out the recall 2 there, not the actual number. If we were in trace mode, I think that would print the result of the register as well. Okay, and we can recall B like so, and recall 2 again. That's about it for this video. I may do some more on this calculator. There's a whole lot more that this can do. I've really just scratched the surface, and I don't profess to know everything about it, but yeah, I think it's a great calculator. It's still useful in today's environment. Pretty handy with the little printer and whatnot, card reader, programmable. So yeah, thanks very much for watching, and keep an eye out for some more videos. I am also going to do some videos on the HP 41, so keep an eye out for that as well, and its peripherals. So yeah, thanks very much for watching.